Hello everyone. There is something about the adjoint. Well, what is adjoint? It is if we have the inner product, we have and by this idea we can introduce a bunch of matrices. So the first one worth noticing is the how to calculate this one. This is called the conjugate transpose. So we have something to be A equals so for this example, the conjugate means we take the conjugate like plus I to minus I to plus I. And A conjugates then transposes which is a adjoint. So every finite vector space have these. Here are when we get confused or we are amazed by the beauty of these operators, because we can do there are many matrices with nice properties that we can explore. First is this. Is called unitary operator. We have U times U equals I, the identity matrix, equals. So what do they have? They're commute and they time to 1. We have U, the inner product of 2 is the inner product of itself, and when we replace beta with alpha, we get we have alpha squared, so U alpha squared, so the norm of u of alpha is equal to the norm of alpha. There are some examples of the unitary matrix. An example is we can quickly write down its adjoint transpose conjugate. Here we calculate and verify. But before that, we notice that in its row and columns, form an orthonormal basis. Orthonormal means is your inner product is 0 and the norm is 1 in that space. So these are two very useful properties which when you observe that the matrix has this, you started to think about the unitary matrices, and let's verify. As U equals its own conjugate transpose, we have so they're equal. To I. This is an example of the unitary operator. What is nice about this is it will extend to the next topic of the normal operator, which is more common, but by looking at this specific example, we can observe that there are very nice bases which are easy to calculate for us.